Yeah, alright. So we're starting the project today. Alright. For the most part, read all these instructions that follow along. I'm going to be skimming over them. So when designing a very large project, you have to usually go over the development process. For almost every major project, you're going to need to do all these steps. First, you need to investigate an idea for the project. Then you need to plan out how you're going to do it. Then you're going to need to design. And all of this occurs before you even start coding. Then you're going to start actually creating and then testing. So today, we're going to be doing the investigating an idea for your project. So the requirements. Your artistic artifact should represent the algorithmic thinking and computing skills you learned so far. So you need to go back and do everything we've already done and combine them all together. So you should be looking back at our previous activities, and you're going to use everything you've done before. So the basic functionality of your program is one, it needs to use a variety of shapes to produce a unique artistic artifact. So it has to use at least a variety of shapes. It can't just be one shape over and over again. Also, you need to use color and size variations to enhance your artwork. Use movement to enhance your artwork. This requirement, I'm currently not making y'all do any animations. It's going to be a static image. If you do a fractal, I would allow if you do some sort of fractal where the motion of creating the fractal is artistic in itself, like some sort of spiral action, in which case the spiral is actually the point of the art is more of an animation. I will allow that. You'll just have to take a lot of screenshots. It must use iteration and conditional execution. So you have to have while or for loops and if statements to control the drawing. I will say you also need to use modulus somewhere into it too. So help in creating your code, you can use existing turtle methods like forward, right. You need to make sure that your variable names are very descriptive. Again, I'm going to be looking over your code, and if I can't understand what your code does, the readability is off. You should write code so that it's readable to someone else. There is a segment though. Let me scroll down. During a project, or when someone is designing, computer science is inherently a team building exercise. Usually one person doesn't program the whole thing. You'll be programming this whole thing because you all have different drawings. But if you want to have a classmate or myself look over your code and see if it's well documented, are the variables well named, we can do that. So let me actually open up the submission file. So I kind of didn't know how to do the submission for this project, because unfortunately as soon as I sign it, I can no longer edit it. So what I did was I gave you a scratch code, a blank document you can copy in. And say I made a copy for each student, and then I broke these sections up. But your main two submission files are going to be So, this I tried to rename this to code submission, put code in front of it, but it didn't take whenever I hit submit. And so when you open up the instructions, I edited this after submitting it. See if code comes after. Actually, now that I know everyone has it, see if that appears in the instructions. Because I want to be able a way to edit the instructions and have it update for y'all. Because once it makes a copy to you guys, I'm no longer able edit it because everyone has their own unique copy. So I broke these sections up. Here is the official grading for future projects. This one is going to be reduced. We use the official AP rules on making a project, and this is just a reduced down version. I think what I'm going to do is have you guys copy from all of this into the document submission file. I'm either going, so currently you should have a copy like this, have you copy all the steps into this, and you'll submit this in total. Either that, or I'll have you come over here, select everything, delete, and just have the required submission part right there. But I broke these up into multiple files for the reason why I can come over here and make comments on these files, and your main submission file will get all messy. So whenever you come up with an idea, it's best to brainstorm several ideas. So brainstorm a few ideas that you would like to create. Avoid going into too much detail. So if you're trying to design a house, don't go into the frames on the door, what type of lock you'll use, um, how many bushes and leaves you're going to put on it. Don't go into too much detail. Do an abstraction of the idea. I'm going to have a house. There's going to be some bushes in front. There's going to be a fence. There's going to be a tree. I'm going to add a roof. So without going into perhaps the shape of the roof and so. Especially also don't be thinking about how you're going to end up creating it. You should be coming up with an idea, and we'll look at how to create it later. You should have been doing a fair amount of brainstorming, storming, and idea generation throughout your education, and also last week at the net. Anything you should be thinking? They did. Okay, so I can update that later. So capture all ideas. Do not evaluate. Never criticize. Work for quantity to allow quality ideas to surface. So, the more ideas you put into the project and while brainstorming, the more ideas you can extract for quality. So if you keep thinking, okay, I'm going to add birds, I'm going to add clouds, I'm going to add sun, I'm going to add bushes, I'm going to add a roadway, I'm going to add a garage, if you keep adding bunches and bunches of ideas, and then you can extract some of the ideas. You may not have time to do them all, but you can eventually come up with a good project. So usually during the brainstorming idea, when designing a piece of software, you add a whole bunch of ideas and you start working through and trying to achieve some of them. Welcome piling on. So let's see, piling on is what? Um, What's the technical name? I mean, it's like stacking and stuff. It's basically adding bunches of ideas. Allow for a free-for-all, meaning that you can randomly select. Also, think big. Go all out. If it's too ambitious, I will tell you to reduce some stuff. Once you're done brainstorming, evaluate your ideas by choosing one or two of your ideas and elaborate on them. So if you're thinking of a house, maybe have some backup plans too. So maybe a car, or because you might find like, oh, I finished it super early. What else can I add to this? Maybe I can combine my ideas together. So maybe add a car or something, or maybe have a painting somewhere. And then so don't just come up with one idea. Come up with a few. That's at least two, and then at the end, choose one of them to fully develop. And then bring your idea, including documentation and sketches, to your teacher for approval before continuing. So by the end of the day, I would like you to come over and actually provide some ideas. Write it out, so do words, and I also want a hand-drawn sketch of your idea. If you come up with multiple sketches, then take pictures with your cell phone. Your computers do have a camera on it, but it's going to be hard to hold it up and click. I'd use your cell phone and add the pictures, so hand draw a sketch of what you want. Again, it could be multiple different things. You could have multiple ideas. But that's the purpose I want done by the day, is to come up with ideas. The next step that you'll be working on tomorrow is the actual planning portion. So software development is often broken into something called milestones. A milestone is a task or other significant event in the development process. Milestones allow you to achieve project achievements and to follow development schedule. There are actual paradigms. There's actual official milestone. Let's see. Programming. Oh, project management. They're sketches. They're just gonna be sketches. No. You can also just draw a line to it. It says red. And you can describe it to you in words. Oh, what's it called? I forget, because there's actual software designed to, when they come up with milestones and plans, there's actually certain techniques where you have to follow in a certain order. You have to actually create milestones day one, and then before you even start coding, so you have to figure out all the milestones you'll do over a year. So you have to plan out the entire year, and then you start working on one milestone at a time. You don't move on to anything else. You only achieve one thing. Once it's done, you check it off, then you move to another one. So break down your project into smaller tasks. Requires problem decomposition. So problem decomposition is the process of breaking down a complex problem into multiple different parts. So for example, if you have a house, you could break up drawing the door, drawing the front part of the building, drawing the bushes, drawing the fence. You can break these all up individually, and you start trying to work on one at a time. and work incrementally. So for the planning, what you're going to do is take your drawing, your idea, and formally identify major parts of the program. So describe the various parts we'll do. So again, the example I gave up because it's the main image, turtle, python, art, I even type house. There's a better picture than this. No, that'll work though. I had the expanded version. Because I can go over here and do it. So, for example, the fence. The fence in this problem can be done independent of everything else. Describe how you will make a single fence post if this was your project. By the way, you can't use this exact one. So describe how you would make the fence post. Maybe you go up, turn 45 degrees, go this length, turn 90 degrees, or to the right, go down, change the line color and thickness. So here you want bold, and here you would want the line thickness and color to change to brown and be 1. Or maybe you want it turned off, and then you have begin fill, end fill to change the entire color inside the brown. And then you want to put this in a for loop and move over a certain amount, maybe 50, so that it will repeat across the screen. And you describe how you make a fence. Then you might have a portion that describes how you make the house. Then you could have a portion that describes how you can make a bush or cloud shape. A portion describe how you can make the sun. And then the portion to make the background. You could describe how to make the roadway. You could also add under the section making the fence how you could add the gate modification. But you can see from this image alone, there's multiple things you could break up. You could even have how to draw a window and how to have it repeat 4 times. So you can take the problem and break it up into sections. That's the purpose of the planning stage you'll do Friday, is how you're going to break up your code. And this is before you even do any coding. So you're going to break it up and describe in probably pseudocode or in words how you're going to achieve that major feature. Decide whether each feature is feasible, meaning decide if it's doable or not. Be sure that all features are feasible and that you will be able to develop them in the time allowed. If necessary, modify your list, moving some features to an optional or nice to have list. Choose what features to develop first. So describe which sections you'll do first in what order, what to develop last, what to develop in between, estimate the time and it will take to develop each feature. These are your development milestones. Document them and assign them to dates. You should have at least one milestone for each day you'll work on the project. So by Friday, you should have Saturday, Sunday, Monday, Tuesday, and Wednesday milestones. Again, this is not something that's going to be able to be done in one day. So that's it. Milestone features programming. It's really feature-based milestone. Feature-driven. It's really aggravating that I don't remember what that's called. There's so many. Computer science, not programming language. That's it. So here's one example: agile software development. That's what I was thinking. So they actually have different approaches. Well, one good one is agile. It's an official way of actually designing a program. So in agile, it's mostly meant for defining, doing like customer based. Customer gives you a program. You do add some features to it. What's the other base one? Agile is not that. Agile is more for company. But there's actually official milestone creation platforms that are official that if you follow it, it guarantees that your software will be good at them. So you need to break up and give you estimates of how long it's going to take you to do a portion of it. So and like I was trying to say, like there's this agile method, and I forget the other ones. Agile versus here's one waterfall. Waterfall is another one. They're very similar. So software development, agile. What's the other good one? I've used one. It's been so long since I've used these. Scrum. Scrum's a good one. I think so. Scrum is actually agile too. Oh my goodness. Oh, here it is. Methodologies and frameworks. So there's Scrum. There's Rad. That's the one I use. Rapid. There's multiple ones. These are basically so required planning. So what you do is you plan requirements, and it's just a process for you breaking up a large process into multiple steps. You follow this methodology, and it allows you to, if you follow it, there's flow-based ones too. Uh, so in real computer science, whenever they come up with it, they literally will break up the program and have a calendar of milestones. And they'll work on it for 11 days. Once at the end of the 11 days, they have to get it done by them. That's the cutoff. So so I'll sit there and try as best as possible to get done. Well, there is no such thing. You have to get it done in 11 days. Sometimes your estimates be off, and you'll have to entirely recorrect it or something. But breaking up into milestones is very important in computer science. So you'll need to break up your program into multiple different sections and try working on one at a time. It is impractical on large projects to try just coding the entire thing in one sitting or to code the entire project at the same time. It's very important that you break up the code, the project into smaller problems that are easier to solve. um, rapid, so rad, software development is actually used in those, I believe. So here during your design, so that's our planning. Once you break it up during design, create more sketches or diagrams of major features. So after you planned on how you're going to achieve some of the things, here you're going to finalize them. This is where, for example, I was planning a house earlier. I knew I was going to do a 3D. Have a door, so I was trying to program this. Again, here in the design stage, you actually start adding major features. Like I wanted it to be 3 windows. I wanted to have a roof. That would the roof's gonna hide the top part of this. Um, But create a more final sketch. You could use paint, or you could actually draw it better. Or you can take grid paper and go in. So before when you get to this point, make sure that it meets all the requirements. So it has to have varying shapes, has to have different sizes between different things. It has to be complex. It can't just be a simple shape. Document which features will meet each requirement. For example, which feature will demonstrate color, movement, iteration. Adjust your feature set if necessary. Again, movement. I don't know if I should make y'all have some animation in it. Because I was thinking you could have something as simple as a bird just flying across the screen. Same thing you normally do. You have a bird and just have it move. I might just ignore the movement thing, but you need to have iteration, so make sure that has something that repeats. Yes? So, actually, I can show you in Paint. I believe the fill color does something very similar. Let me. So, freeform select. So, if I come over here and draw this shape, it would look at the starting position and end position. So, it will draw a straight line like that. And if I do something like this, it'll do something like that. Kinda. I think that's how it kind of works. Just play. You would have to play around with it. I know in order for me to paint this side, this color right here, I would need to redraw over this line. Go up here, go over here, and go here. I don't have to draw this last one, but you can just go ahead and do it. Note that if I come up here, draw this line, then I draw this line, and then I draw it up here, what it will do is it'll look very, very weird. So if I draw this line right here, then this line right here, and then this line, it doesn't do like the select tool. It actually is very different. What it does is it pieces straight line segments together mathematically and tries to draw polygons between them. Yeah, I mean, you just play around with it. You'll have to do one shape at a time. As long as you have like something that is enclosed like this, it will actually do it correctly. But if you do something more like if you do something more like this, draw it like that, and then you come over here and draw like a line like this isn't going to work because you drew this line first, this line first. But if you instead had drawn this, because this is an convex, convex polygon, it will fill it. So decide if any features you need, comment. So this will be done over the weekend or Friday too. Well then these two will have to be done Friday for you if you can't do it over the weekend. Because I don't recommend you start coding on Monday. Because that will leave you just Monday, Tuesday, and Wednesday. You shouldn't. You should design it all out and then break it up into multiple pieces. Yeah, you can. You can. So yeah, you can go ahead and if you wanted to, already start on your planning and your designing today. But you should be doing this in order of steps. What do you? Yeah, that's what I showed first thing. Hmm? No. So here's the individual sections. Like here's the planning. Here's the first one. This is where you'll have rough sketches, very crude. The design is where you have your like final sketch. Your plan is where you break up different segments. Create and test is the portion. Again, I don't think you're gonna have to fill these out. But I do want this one, and this one filled out. These first three for sure. Oh yeah, six definitely. Six. See, I don't know if I'm going to have you guys combine all six of these into your document submission, or just have your document in there. I don't know that yet. I'll figure that out by Monday. That's why you should be definitely working. So for remote learners, code word. There's the code word. Uh, so it doesn't say that it needs it, but I would like you to use everything we went over, meaning that I also want in addition to these rules. So in addition, let me actually not that one. So additional requirements program must get some user input. Um, uh, color and a variable number. Make sure to comment what default values should be, and must use modulus somewhere. Maybe alternating colors. So during the create portion of it, you'll be creating milestones, using pseudocode as comments, if necessary, adjust them. So you can come in to your sections and just make pseudocodes in all your sections. Keep it on commented using the string. So you can do the quotation, 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 and just have it. This is just testing. And then as you start working on a new milestone, you'll come over here and actually remove the pseudocode, or underneath the pseudocode, actually start writing the program for it. And actually start coding it. Remember to use debugging techniques if you run into programs. Check your feature meets requirements. As you add new features, test previously developed features to ensure that they work. I highly recommend, like if you're working on Fence and you get Fence all working, go copy and paste and make a copy of your program before you start working on your next feature, in case you break your entire code somehow. So evaluate the solution. You can either ask me to look at it, or you can ask a student to look at it. Since y'all all should have very unique drawings. So if you share and look at code and stuff, as long as your drawings are unique, y'all can share between each other and look at it. They can share with me or one of y'all. And what I think you can also do is when you up and up. So here's the evaluate the solution. I think you have permission to come up here and hit share. And you can share it with the other student, and they can get it and look at it and edit in the same file. I don't know how that's going to work. But here's the document and present. So you'll need screenshots. Running out of time. You'll need screenshots. Again, we're going to be using College Board's create performance task. This course is designed to meet the requirements of AP. Even though our school doesn't do AP. This class is able to be submitted as an AP class, and they actually use create performance tasks. But for the first project, it's going to be very minor. I copied the instructions for create. So you'll need to have high quality screenshots. On y'all's browser, there's something called Screencastify. It's a screen video recorder. You can use it to take snapshots. There's also something called Snapping Tool that you can click on and create a screenshot of. That's what I personally use to create screenshots, a Snapping Tool. So they have to be high quality. So create good quality screenshots. Identify the purpose of the program and explain what the screenshots illustrate. So describe the screenshots. Also, here is one important thing. You will select 2 programming code segments. So you'll copy and paste 2 segments, and you will describe. So you need to select one programming statement and show how initial data has been stored in a list. So show how you stored something into a list. Describe it. And copy and paste the segment. And then in another segment, show how the data in the list is being processed and used. Be sure your discussion identifies the name of the list being processed. So for example, if I come over here and did var, you copy and paste for loop and say that my variable is called new underscore list. I am creating a turtle, giving a default color and pushing it into the list, or appending it to the list. No, it's going to be in the document form. Describe one code segment related to the selection. So select one of these 2 code segments. So describe one of them. A selection determines which part of. I think I'm misreading this. Describe one code segment related to the selection. Selection determines which part of an algorithm are executed based on. Describe another code segment related to a conditional. And then you'll submit your work. Again, I think mainly it's going to be these 2 files that I'll look at. Along the way, I'll be looking at your individual steps. Let's see if I have time. Here's create performance task. I got literally a minute. So if we were submitting this to an AP class, how they want them to submit is you have one PDF file containing your entire program code. We're not doing that. Must use a list. Must use a procedure, meaning a function. So the difference between Buck actually asked this. procedure is a function. Technically, it's a function that doesn't return a value. But for most purposes, a procedure and function are the same thing. Oh, and look, they actually do the return type if necessary. Procedures technically don't have a return type, so procedure is a function in this class. And here you have to do a video whenever you submit projects. We're not doing that though.